Good. Welcome to calculus. And so for the first day, we'll basically be a bit of review on stuff we want to go forward in the algebra class. And so we have first, in terms of what is slope. So slope is given to be rise over run over the change in y over the change in x, which in terms of formula became y2 minus y1 over x2 minus x1. And everybody should be familiar with that, seen that before. And so, for example, you got given 2 points, determine the slope. So if I got points over 7 and 20, and I want to know what is the slope, well, we call this x1, y1, x2, y2, and then we can take those numbers and plug them into that equation. So my slope will be 20 minus 7 over 7 minus 4, and that would come out to be 13 over 3, and that would be my slope. Again, everybody should have seen that before. Again, slope will be, if it is an improper fraction, we'll leave it in that way. We're not going to change that to a mixed number. If it came out to a whole number, then we would simplify to that whole number expression. But slope. And so mainly calculus deals with slopes. There's 2 parts of calculus. First part is slope. The second part deals with area. And so we'll be seeing this equation again in a slightly different form a bit later on in today's talk. Well, in terms of that, we also had, and you've seen before, in terms of an equation of a line. And so there are several ways of writing it. The 2 we'll be concerned with here will be the slope-intercept form, which is probably the more common way you see the equation of a line, and that is y equals mx plus b. When the equation was written in this form, then we have the m, this was the slope, and the b, this was the y-intercept. And so, for example, if you had an equation that looked like this, y equals 3 plus x minus 7, then by looking at this equation, I know that the slope is going to be 3/5, and I know that the y-intercept will be -7. And I can read that directly off my equation. So then we had, well, let's say I give you 2 points, and I want to know the equation of the line. So let's say we have the points 2, 6, and then 5, and let's make this 12. Again, the first thing we can do is we can find the slope. So x1, y1, x2, y2. So the slope will be 12 minus 6 over 5 minus 2. So this will be 6 over 3, which will be 2. Okay. Well, if I want my equation of the line in the slope-intercept form, which means I want the equation in the y equals mx plus b form. Well, I know the slope. I know that this point's on the line. I also know that point's on the line. So I can either take either one of those 2 to do this. But let's take the first set, which was 2, 6. So this will be the x. This will be the y. And then that number is my m. And so we get 6 is going to equal 2 times 2 plus b. So 6 equals 4 plus b. And if we solve that equation for b, we find out that b is going to equal 2. So my equation is going to be y equals 2x plus 2. would be the equation of the line in slope-intercept form. Well, the other way you could write an equation of the line was in what was called point slope form, which was y minus y1 equals m x minus x1. So when the equation was in this form, m represented the slope, and then x1, y1 was the point. So for example then, we want to find the equation of the line given these 2 points. So let's say now we got that the points are 3, 5, and 6, and 12. So the first thing I want to do is again find my slope. And so my slope will be 12 minus 5 over 6 minus 3. So this will come out to be 7/3, which is a fraction. We'll leave it in that form. And now if I want the equation in this form, I just need to pick a point. So let's take the point 3, 5. Okay. So we'll call this x1, we'll call this y1. So all I have to do is take these 3 numbers and plug them into these 3 places, and I have my equation. So we'll have y minus y equals 7/3 x minus 3. And that would be the equation of the line in point slope form. But now, what if I want to actually put that into slope-intercept form? Well, I can take that equation and I could solve it for y. So if I do that, I get y minus 5. Take care of my distributive properties. This will be 7/3 x. 7/3 times a minus 3 will be a minus 7. Next step is to bring the 5 over. Add 5. Add 5. And we get y equals 7/3 x minus 2. And that would change from point slope into slope-intercept form. So we have slope, intercept, and we have point slope form. Well, then it would be, well, come up with the equation given you now have a word problem. So given a company charges an initial fee of $10 plus an additional let's say 25 cents per mile. What would be the charge? So company charges an additional fee of $10, and then it's 25 cents per mile. And I want to know, well, how much would you pay if you go 20 miles? Well, first off, what is my equation that gives me this? Well, the cost is going to be the $10, 25 cents per mile. Well, 25 cents in terms of dollars would be 0.25 times x. Which, if I change it back into my slope-intercept form, I could also rewrite this way. They both say exactly the same thing. Right? So that would be my equation that goes with those set of words. And now the next step would be, now that we have the equation, is solve it. so when x is 20. So the cost is going to be 0.25 times 20 plus 10. Well, 0.25 times 20 is 5. 5 plus 10 is going to be 15. So my cost here for this scenario will be $15. So we can come up with an equation that relates what's going on here in terms of this. Okay? So let's say I have 2 points on a graph. So let's say I have this point, which will be at the point 1, 1. And then I have this point up here, which will be at the point 4, 5. Right? And I want to know, what is the distance from here to there? What is the length of that row line? So what is the distance here? Right? Well, if I look at this, I could make this into a right triangle. I could take this straight across. I can take this straight down, and I have a right triangle. And I would get that from here to here is 3 units. And from here to here is 4 units. And so I could find the distance by using Pythagorean theorem. A squared plus b squared equals c squared. And so I would have that 3 squared plus 4 squared is going to equal c squared. So 9 plus 16, so 25 equals c squared, and so c is the square root of 25, which would be 5. So we get that. Well, we could also find this by what is called the distance formula. And the distance formula basically is just the Pythagorean theorem rewritten. And so we got d is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. So now if I take my numbers from my 2 points I got here, let's call this x1, y1, x2, y2. If I take those numbers and plug them in, we got that my distance t is going to be the square root of 4 minus 1 squared plus 5 minus 1 squared. Well, 4 minus 1 is 3, and so this will be d is going to be the square root of 3 squared. 5 minus 1 is 4, this will be 4 squared. So this is the square root of 9 plus 16. So the square root of 25, and that will be 5. Okay. So the distance formula then is just Pythagorean theorem rewritten. Okay. So given 2 points, we can find the distance in between 2 points by using the distance formula. So we have, in terms of an equation, so let's say I have something like this. Y equals 2x plus 3. And I say, okay, solve this when x is equal to 5. Right? So what this says is, here's my equation. I tell you x is 5. I want to know what y is. So y is going to be 2 times 5 plus 3, and that'll be 13. So we can now talk about what are called functions. And so functions, and what makes a function is that for every x, you only get one y value. So basically here, for every number I plug in for x, I only get one answer. So for every x, there is only one y. So therefore, this is a function. Right? And so I can rewrite this as f of x equals 2x plus 3. Same thing, right? And now, if I ask you what is the f of 5, well, it would mean 2 times 5 plus 3. We end up with 13. So for a function, you have to have for every x number you plug in, you only get one y number out. Okay? That's what makes a function a function. Well, if I look in terms of my equation here, I can also talk about what is the domain and the range. The domain refers to the x numbers you plug in. So really, what numbers can I plug in for x? Well, in the case of this thing, I can plug in any number I want for x. I can plug in negative numbers, I can plug in 0, I can plug in positive numbers. No matter what I plug in, I can get an answer. So the domain here will be all reals. Right? The range refers to the y numbers. So the range refers to the y values. So once you plug in all those numbers, what kind of answers do you get out? Well, if I plug in to that, if I plug in negative numbers, like negative 10, I will get a negative answer. I can get 0 out of that. I can get positive numbers out of that. So my range here is also going to be all reals. So in this case, my domain is reals, my range is also reals. Right? So again, domain refers to the x, and range refers to the y numbers that you come out. So given an equation then, given something like this, you have to figure out, well, is it a function or not? So let's say y equals x squared plus 3. So is it a function? Right? So is it a function, which means is this true? Well, so every x number I plug in, okay, will I only get one answer? Right? And so the answer here is yes, I will only get one answer for every number of x I plug in. And my domain for this is, well, I can plug in any number I want. So my domain is all reals, and my range is also all reals. Okay? Or is it? Okay, is it going to be all reals in this case? Well, if I have a number and I square it, okay, it will be a positive number. And so I will get only positive answers, okay? And the smallest value that this thing can take on will be that y has to be greater than or equal to 3. I can only get numbers that are either 3 or greater, okay? Because if I take an x number and I square it, it will be a positive, which means the minimum will occur when x is 0. And 0 squared plus 3 will be 3. So my domain is all reals. My range will be that y will be greater than or equal to 3. So in terms of function, the way you can tell a function by looking at a graph, is this. So let's draw some graphs. 1, graph 2, graph 3, and graph 4. And let's draw some polygons here. So let's say I have this. Let's say I have something that looks like this. I have another one that looks like that. And then I have one that looks like this. Right? I have 4 possibilities here. So let's call this is graph A, this is graph B, this is graph C, and then let's call this graph D. So those are my choices, right? So you think back to when you were younger, way younger, and back to TV shows you may have watched, one of those being Sesame Street. You got to that segment of the show that said one of these is not like the other. And in the case of this, one of these is not like the other. And now one of these actually is a graph of a function. Right? And so the way you tell if something is a function, it has to pass what is called the vertical line test. So if I take a vertical line and pass it through, so here, you got to cut it in two spaces. Therefore, that's not a function. If I do graph B, I see everywhere it cuts it in only one spot. So B is a function. I go to graph C, I get some places it cuts it in three places. And then I go to graph D, again, it cuts it in more than one spot. And so graph B is the only one that is of a function. So in terms of giving a graph then, so let's say we got something that looks like this. And let's see, it goes from here, and it goes across to here, and then it goes up there. Right? And let's call this point -4, -5, that point. And then at this point, let's put an open circle. And we'll call this point 10, 11. So first off, is it a graph of a function? Yes, it is, because again, everywhere along here, it only cuts it in one spot. And then I want to know what is the domain? Well, the domain here is from -4. And it's a closed circle, which means it can be -4. And then up to 10, but not including 10. Okay? Because 10 has the open circle. And the other way I could write this is -4. The closed bracket means it includes the number. And then the parenthesis means it just goes up to 10, but not including 10. We could also do the same thing with the range. The range is the y values are from -5, and it can be -5, up to 11, but it cannot be 11 because of the open circle. And again, in terms of notation, this would be -5 to 11, again, closed bracket there, and parenthesis there. Okay? So that would be in terms of domain and range given a graph. You should be able to do that. So in terms of domain and ranges, so given an equation, can you determine the domain and range? So given some of this, y equals the square root of x squared of x squared, let's just do x plus 3. Well, what's the domain? Well, square root has its own special quality about it, in that you cannot do square root of negative numbers, which means this will only be true when x plus 3 is greater than or equal to 0. So if I solve this for x, you can subtract 3, subtract 3. So my domain here is that x has to be greater than or equal to -3. That would be my domain. X has to be greater than or equal to -3 for this to work. So square roots has its own special things. Other functions that have their own special things are logarithms, natural logarithms. So you have to be aware about those and how those work. Well, functions. Okay? This is what we deal with in terms of calculus. We had our slope formula earlier, which was y2 minus y1 equals x2. Okay? So y2 minus y1 over x2 minus x1. Right? Well, let's say I now have a graph again. And let's make it a graph of a curve. So something that looks like this. Right? And I want to find slope. Right? So let's call this the point x. Let's call this some other point, which will be x plus delta x. And so if I take this up, read across, this will be f of x. And then if I take this one up, and move this across, this will be f of x plus delta x. So I can rewrite my slope equation, again, in terms of this. And so my slope will be f of x plus delta x minus f of x over x plus delta x minus x. Okay. And this will simplify a bit, that my slope is going to be f of x plus delta x minus f of x over delta x. These x's will go away. So that is my slope equation again. It basically is the same as what we just had in terms of y2 minus y1 over x2 minus x1. It just rewritten slightly differently. So for example, let's say I want to find my slope for a given function. So let's say that my f of x is given by x squared. Okay. So that's f of x. We said we could do f of 5. We could just plug in the 5 and we end up with 25. Right? So if I did, well, what is f of 5? That would be 5 squared, which would be 25. But now, what is f of x plus delta x? Well, what is f of x plus delta x? Well, it means the same thing. Take the x out, but this time plug in x plus delta x. So this will be x plus delta x squared. Right? Well, what does that mean? This means x plus delta x times x plus delta x. And so we can multiply that out. That's just FOIL method. X times x is x squared. X times delta x will be an x delta x. Delta x times x will be another x delta x. And then delta x times delta x will be delta x squared. And then this can be simplified. We'll get x squared plus 2x delta x plus delta x squared. So now we can plug this into my formula for slope. And so we got that my slope will be this one, x squared plus 2x delta x plus delta x squared minus my f of x, which was x squared, all over delta x. So let's simplify. You got an x squared minus an x squared, so those go away. So we get 2x delta x plus delta x squared all over delta x. So if I look at this in terms of my numerator, I notice that there's a delta x common to everything in the top, so I can factor that out. And so if I factor that out, we get delta x. This will be 2x plus delta x over delta x. So that means that this and this will be my equation for my slope. So for example, if I gave you something like this, I said, okay, well, let's say that point 1, in terms of on this, was given to be 2, 5. And my second point on here was going to be the point 3, 9. Okay, this is point 2. Well, what is the slope? Well, the slope says, this says that my slope will be given by 2 times my x, which so 2 times 2, plus the change in x. Well, the change in x from 2 to 3 is only 1. My slope will be 5. That point. So 2 times the x plus the delta. So then, given something like this, given this equation, all right, so what is the slope? Given that f of x is equal to x squared plus 3x plus 2. Right? So that's the f of x. So what we need to know is what is the value of f of x plus delta x. So f of x plus delta x is going to be x plus delta x squared plus 3 times x plus delta x plus 2. Well, we saw earlier what this became x squared plus 2x delta x plus delta x squared. That's that part. 3 times this will be 3x plus 3 delta x plus 2. So we now have my pieces. I know what this part is. This is this. We know what that is. And so we can now do the formula for slope. So my slope is going to equal x squared plus 2x delta x plus delta x squared plus 3x plus 3 delta x plus 2. That part minus my f of x, which is x squared plus 3x plus 2. All of that over delta x. So all of this stuff in red minus that in the bottom. But this can be simplified a bit. So if I look at this, we got that the slope, so we got an x squared here minus an x squared over there, so that goes. We have a 3x minus a 3x, so that goes. And then we got a 2 minus 2, and that goes. So we're left with 2x delta x plus delta x squared plus 3 delta x all over delta x. Well, again, I look at the top, I see that delta x is common in every term, therefore delta x can be factored out. And so if we do that, we get delta x, 2x plus delta x plus 3 all over delta x. And these will go away. And we're left with 2x plus delta x plus 3. And that would be the equation for the slope given my original equation here. So in order to use this formula, we need to know what is f of x. We need to know what is f of delta x, and then we just plug it in and go through the steps. Right? And that is the slope. Right? Well, we look at an equation, and let's say we want to know, well, what happens when we get to a certain point? Right? And so we can get to what are called limits. So, for example, let's say I want to know what value does this take on. So what is the limit as x approaches 3 for this equation, 2x plus 2. Now, so basically, for this one, because it's just a nice linear equation, I can just take my number x and I can plug it in. So I can say, okay, well, if x is 3, where does this come out? This comes out to be, well, this would be 2 times 3, which is 6 plus 2, that'll be 8. If I have one like this, what is the limit? As x approaches -4, and I had x squared minus 5. Well, again, I can take the number and just plug it in. And so -4 squared is 16 minus 5. This will give me 11. So if you can just take the number and plug it directly in and see what you get. But what happens if I have one like this? What is the limit of, let's say, 5 over x plus 2, but now x is going to -2. Well, this time if I plug -2 in, I get 5 over -2 plus 2, and -2 plus 2 would be 0, and 5 divided by 0 is undefined. I cannot do it. So we now need to figure out, well, what's going on here with this. So we need to come up with numbers that are close to -2, but not quite -2. So, for example, let's say that x is -2.1, -2.01, -2.001. Right? If I plug in those numbers, what numbers do I get? So we can plug those in and see what happens here. Right? So 5. So this comes out to be -50. The next one will come out to be -500. And the next one will come out to be -5,000. Right? And okay, so that's if I'm doing numbers that are bigger than negative. What about if I go to the other side and say now that we got -1.9, -1.99, -1.999. Right? So if I do this, I get 50. I do this, I get 500. And I do this, I'll get 5,000. Okay? So one thing you notice here is if I come in from numbers that are less than -2, I'm heading towards negative infinity. If I come in from the other side, I'm heading towards positive infinity. So for this one, the limit is not applicable, can't be done. So in order to have a limit, you have to be approaching the same number no matter which direction you come in from. Right? And so this case, we come in one way, we go to negative infinity. I come in the other way, I'm going to positive infinity, therefore it has no limit. Right? So if you cannot plug the number in, we need to do this kind of a chart and see what happens. Right? Well, what happens if I have one that looks like this? What is the limit? And let's say x plus 4 over as x goes to -4. Right? Well, what happens if I plug in -4? Well, if I plug in negative 4 in here, negative 4 squared, this will be 16. 7 times negative 4 will be a minus 28. And then we got a plus 12. Well, if I look at that, that will be 0. We have a problem. Well, but I also notice that this is a quadratic. It's also a factorable quadratic. Right? So the top is x plus 4. This can be factored, x and x. Both are positive, so both of these are positive. And then we need two numbers, multiply together to give you 12, and have a total of 7. And that would be 4 and 3. So now if I look at this, we have an x plus 4 on the top, we have an x plus 4 on the bottom, and so those will go away. This will become a 1. And so now that I factored it out and I got rid of that term, we can now plug in my negative 4, and we end up here that the limit here will be negative 1. Okay? So by factoring that quadratic, we got rid of the problem, and now made it again that I can plug in the number and solve. Okay? So you have in terms of limits. Well, calculus is broken out into basically two branches. The first branch of it is called derivatives. And derivatives basically refers to the slope. So if I have a curve, for example, like that, and I want to know what is the slope at this point. I want to know what is the slope of the curve at that particular point. Well, we said in order to do slope, I need to have 2 points. Right? Right? So I need to have 2 points in order to find out slope. So if I take this point and this point, is that okay, what's the slope? Well, that's probably not going to match very well what's going on here. Right? So in order to get a good approximation of the slope, I want the x plus delta x to be very small. Okay. So if I want to know what is the slope of this particular point, I want to get 2 points that are really right on top of each other. In fact, ideally, we want x plus delta x to be so small that delta x is going to be so small that delta x is basically 0. Okay? So we want delta x to basically be 0 here. And so we get to derivatives, and derivatives are given by a limit of f of x plus delta x minus f of x all over delta x. So the same equation I had before, except for now we have the added feature that delta x is going to 0. So if I go back to one of my previous points we had up, we said that f of x was x squared plus 3x plus 2. And then if we use f of x plus delta x, we get x plus delta x squared plus 3 times x plus delta x plus 2. And then this became x squared, 2x delta x squared plus 3x plus 3 delta x plus 2. Okay. And now if I take this information and I plug it into my equation for my derivative, so my derivative, we got the derivative here is going to be the limit as delta x goes to 0. And then it's going to be f of x plus delta x. So x squared plus 2x delta x plus delta x squared plus 3x plus 3 delta x plus 2. That's my f of x plus delta x minus my f of x part, which was x squared plus 3x plus 2. All of that over delta x. So we got here again that the x squares go away. This and this go. The 3x and the 3x goes, and the 2 and the 2 goes. And so we're left with the limit as delta x goes to 0 of 2x delta x plus delta x squared plus 3 delta x all over delta x. Again, if I look at the top, we said that the delta x can be factored out. So we get delta x comes out, we get 2x plus delta x plus 3 delta x over delta x. The delta x's go away. And so what we want to know is what is the limit as delta x goes to 0 of 2x plus delta x plus and actually sorry, I forgot to take that one out of there. So that should be 3 plus 3. Okay. Well, so now I want to know. Now I can actually take my number and plug it in. So if delta x is 0, we find out the limit here is 2x plus 3. So if I want to know the slope at any given x value for that original equation, I can just take my number and plug it in. So I can say, okay, well, what is the derivative for this one if x is equal to 10? Well, it would be 2 times 10 plus 3, which is 23. So we got our derivative, right? Well, calculus and where calculus comes from is part of it comes from the work of Isaac Newton. And when he was doing all his physics work, he needed a way of expressing his quantities, so that's where we got calculus from. Right? So if you think about speed, speed is a derivative, it's a slope. Because after all, it's the mileage divided by the time, what speed is. Acceleration. Acceleration is the change in velocity over the change in time. So acceleration is also a derivative. Right? So if you think about speed, you can talk about your instantaneous speed. So instantaneous speed is how fast are you going at any given moment in time. And one way you find out that if you're driving your car is you just quickly look at your speedometer and you get your speed. Right? So speed and acceleration are derivatives. Right? The change of one quantity with respect to the other. So change in distance over change in time for speed. Acceleration is change in velocity over the change in time. Right? So we have here in terms of equation of a line, slopes, and then going into the function way of writing those down, finding the limits, and then my equation, my definition of what makes a derivative, which was this. Okay? And so then being able to use that, this equation in order to get a derivative given any segment equation. Right? And that will conclude this first lesson.